Hey guys, welcome back. So what we're looking at today is 7.1 under construction. So let's go ahead and jump right in. So what we're going to be looking at here are a lot of constructions and taking and using compasses, rulers, and such to take and make these. So obviously, if you're at home and you don't have a compass or ruler, do try your best. If you don't have it exact, that's okay. I completely understand. My drawings aren't going to be the greatest on here simply because I can't use the compass or rulers with the computer, unfortunately. So what we're looking at here in this first one is using a compass, draw several concentric circles that have point A as a center, then draw those same size concentric circles that have B as a center. What do you notice about where all the circles with center A intersect all the corresponding circles with center B? So concentric circles, that just means a circle inside a circle inside a circle. So it's multiple circles that all have the same center but have different radii. So center of A, and then we're just going to go, there's a circle. Obviously my circle's terrible. Hang on. There's a circle, sort of. There's another circle. And there's another very terrible circle. Obviously, my circles are not very good, so this won't be exact by any means. I apologize for that. Do try your best. If you have any circular objects, use those to help you. Now, what we want to do is now we want to make these same size circles around point B. So looking at this, we've got this for our radius, so we want to try and make that the same. So it's going to be about, gracious, that's about halfway. So let's see up there, something like that. Then the next one will be like so. And then the last one, something like that. Obviously, my circles are not perfect, but if we look, all of these circles, they intersect each other. Now, my line is nowhere near straight because my circles are not perfect, but if we did this exact, if we had a compass, or if I had a compass to take and do this exactly, we would find that all of these concentric circles intersect each other at the midpoint, at the same exact point. So it finds the midpoint of the line segment. So it finds the midpoint of the line segment. All right, so for problem 2, in the problem above, you demonstrated one way to find the midpoint of a line segment. Explain another way that a line segment can be bisected without the use of circles. So the interesting thing here is because we're dealing with constructions, we can think about it in terms of we fold it in half. We could also measure it. So we can say measure it or fold the line in half. So that's what we're looking at there. So lots to do with creating circles and finding these different parts. So making constructions of the same shape. So we've got a line here. We want to make the same line at the same angle. Copying entire angles, same thing. Constructing a rhombus, make a circle about it. All right, so the one we're going to take and do together here are the two most complicated. So for 7, we want to construct a square on the segment CD that is given below. Be sure to check that your final figure is a square. So first thing we want to do is draw two circles, one centered at D, one centered at C, that intersect to give us our midpoint. So we want them to be the same size. So I'm going to do this right here. And then this. Okay, they're a little wonky, but you get the idea. So now, let me make this a little thicker. This right here would be the midpoint of this line segment. Now we want to take and draw a circle that goes perfectly from C to D and goes through this intersecting point up here. So let me shrink this back down. So we're going to go just, oops, that was a little low. So we have that. Now we're going to take and draw a circle that goes about C and that has a radius to the midpoint. So it's going to go right, oops, wonky, right like so, kind of, sort of. Now, if we take and draw a line from here, now obviously mine is a little off, so it's not perfect, but it should work out that we would have a square that should have ended there, and then over to our midpoint there. So our square should have ended up right there. Obviously, like I said, mine is not exact because I'm not using a compass, so do try your best when you do these. Now, for 8, given the equilateral triangle below, find the center of rotation of the triangle using a compass and straight edge. So what this means is to find the center of rotation, it's finding the exact center. So what we want to do is bisect each side of the triangle. Where they intersect, that's the center. So bisecting the triangle just means that we're going to go from the angle or the vertex straight to the middle of the other side. We're going to do the same thing here and here. So we find halfway between, and so this point here in the center, that is going to be our center of rotation. So our center of rotation is this point right here. Okay. All right, now we do have a few systems of equations. I'm going to do 3 of them with you, so you only have 3 left to do on your own. So looking at this first one, we're going to use substitution to take and solve because we have x by itself. So that means we're going to have 2 times, now we plug in everything that x is, 11 plus y equals 19. What we want to do here is we want to get an equation that's all of one variable. So we have y and y. Both are variables are y, so it works. Now we distribute the 2. So we have 22 plus 2y plus y equals 19. Combine like terms. 2y plus y is going to be 3y. So we have 22 plus 3y equals 19. I know I'm running out of space here. So now we subtract the 22. So minus 22 minus 22. So we have 3y equals negative 3. We divide by 3. So y equals negative 1. Now we need to plug that back in to find out what x is. So we've got x equals 11 plus negative 1. 11 plus negative 1 is 10. So we have 10, negative 1. That's our solution. All right, our next one. So this one here we can't use substitution for, but we can use elimination. I'm going to multiply this bottom equation all by 3. That way my y's have the same coefficient. So multiply by 3. So we have, and I'm going to write it up here just so I have plenty of space. So we have negative 4x plus 9y equals 9. This will be a 3x minus 9y equals negative 18. So I just multiplied every single one of these by 3. Now I'm going to add these together. I'm adding because the signs on our y values are different. They're opposite. So negative 4x plus 3 is going to give us a negative 1x. These cancel, and it equals 9 plus negative 18 is going to give us a negative 9. Now we divide both of these by a negative 1, so x equals 9. So we know what x is now. X is 9. Now we plug that 9 back in to find what y is. So I'm going to plug it into the bottom equation. So 9 minus 3y equals negative 6. So we subtract 9. We end up with negative 3y equals negative 15. Divide by negative 3. So y equals 5. So our solution is 9, 5. All right, and the last one I'm going to do, 14. Once again, this is one where we have to multiply to make it so our coefficients are the same on a variable. Once again, I'm going to cancel out my y's, so I'm going to multiply the whole top equation by 2. So we'll have 8x minus 2y equals 14, and negative 6x plus 2y equals 8. Once again, the signs on my 2y are opposites, so we add these. So 8 plus negative 6 is a positive 2x. Those cancel, equals 14 plus 8 is going to give us 22. So we have 2x equals 22. We divide by 2. So x equals 11. So 11. Now we need to plug the 11 back in to find out what y is. So I'm going to take, let's see, 4 times 11 minus y equals 7. So I've got 44 minus y equals 7. We subtract the 44. Subtract the 44. So negative y equals negative 37. Divide by negative 1. So y equals a positive 37. So my answer here is 37. So a little refresher, a little reminder on those systems of equations. So you only have 3 left to solve, 11, 12, and 13. These two, 12 and 13, use substitution to solve. 11, you can use elimination and subtract the 2 equations since your x's are the same. All right, your keyword for this lesson is constructions. Constructions, because you have a lot of constructions to make in this one. So if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.